Hi everyone. So welcome back to Power Electronic Control of Drives online series. Now we are in the third unit. So in previous class we have seen the Class C chopper fed DC motor drive, and today let us see some problems. Okay. After that only we have two topics are there. Those are Class D, Class E. This is one topic, and another one is closed loop operation of the chopper. That is only one block diagram is there. Yes, let us we'll see that block diagram, and I will explain and each and every content in the block. Okay. Yes, most probably. So it will take 2 to 3 hours. So meanwhile, so we'll solve some problems. Yeah. Let's read in the problem. A DC chopper feeds a DC chopper feeds a DC chopper feeds power to power to an RLE load an RLE load with R is equal to 2 ohms, L is equal to 10 millihenries, and E is equal to 6 volts. Is equal to 6 volts. If this chopper is operating at if this chopper is operating at chopping frequency of chopping frequency of 1 kilohertz 1 kilohertz and with duty cycle of the duty cycle of 10% 10% from a 220 volts DC source. A volts DC source. Determine the maximum and minimum currents taken by the load. Determine maximum and minimum currents taken by the load. Taken by the load. Okay. This is the problem they have given. It is very simple. That is, you need to find just IO max and IO min. Okay, but here the thing is, you need to remember those formulas. If you don't remember, in the sense, you cannot solve this. So here, just to see what is the information he has given. Yeah, the first one is, it is DC chopper feds power to an RLE load. R is given, L is given, E is given. That means we can assume this is one motor. He has given the motor constants as EB is given, so motor values as EB is given, armature resistance is given, and armature inductance is given. Yes, very good. If this chopper is operating at chopping frequency, he has given chopping frequency. Chopping frequency in the sense f is equal to 1 by t. That means indirectly he has given the total time period. Total time period is equal to 1 by f. Okay, 1 by 1 kilohertz. That means 1 milliseconds we get. With a duty cycle of 10%. That means gamma has given as 0.1. From a 220 volts, that is, he has given Vs is equal to 220 volts. This is so. Now you need to find IO min and IO max. Okay, yes, first let us write the data whatever we want to find the IO max and IO min. Yes, he states that inductance is 10 millihenries and resistance is 2 ohms. With this, what we can find? Can find the time constant. Tau is equal to L by R. L by R. So this is 10 into 10 power minus 3 divided by R. So hence, how much this value? R in the sense 2. 10 by 2 is 5. 5 into 10 power minus 3 seconds. Okay, as F is given, F is equal to 1 kilohertz. From this you can able to find the total time period as 1 by F, so which is given by 1 into 10 power minus 3 seconds. 1 into 10 power minus 3 seconds. And duty ratio is 10%. That means gamma is equal to 0.1. Okay. Then what about the T on? Duty ratio is 0.1 in the sense we know that it is T on by T, and we know T also. Therefore, T on is equal to 0.1 into T. So that is T on is equal to 0.1 into T in the sense 0.1 into 1 into 10 power minus 3. That means 0.1 into 10 power minus 3 seconds. Okay, and next Vs is 220 volts. Vs is 220 volts, and E is equal to 6 volts. Yes, E is equal to 6 volts. Yes. So now let us we find back EMF. Let us we find the IO min and IO max. Yes. First write the equations. Yes, IO max is equal to IO max is equal to, that is, Vs by R into 1 minus e power minus t on by tau by 1 minus e power minus t by tau minus Eb by R. This is the equation. In the place of Eb, I will consider Em. Now let me substitute all the values. So here Vs is 220 volts divided by R in the sense 2, 1 minus T on time period is e power minus e power minus 0.1 into 10 power minus 3 by T in the sense 5 into 10 power minus 3. 5 into 10 power minus 3. divided by 1 minus e power e power what is minus t by tau, t in the sense minus 1 into 10 power minus 3 by 5 into 10 power minus 3. Okay, yes, minus eb by r, eb by r in the sense 6 by 2, 6 by 2. Okay, and here you can cancel these values. Yes, what are the things you can cancel? 10 power minus 3, 10 power minus 3 will get cancelled. Yes, what is the remaining thing? 220 by 2 is 110 into 1 minus, yes, what is the value of e power minus 0.1 by 5? Minus 1. Yes, this will be 1 minus this value, and all together it is 0.0198 approximately divided by 0.1 minus e power minus 1 by 5. Use your calculator and check whether these values are correct or wrong, because I am using the mobile calculator, so it may be 0.181 minus 6 by 2 is 3. 6 by 2 is 3. Okay, yes, then this will be IO max is equal to 12.033 minus 3 is around 9.033 amperes. 9.033 amperes. So this is the value of IO max. Similarly, can we find IO min? Yes, yes, we can. That is, IO min is equal to what is the formula? Vs by R into e power t on by tau minus 1 by e power t by tau minus 1 minus EB by R. So here also in the place of EB, let's we take the value that is E, and we substitute all the values whatever we know. This is equal to Vs in the sense 220 by 2 t by 2 into e power e power t on by tau. Yes, 10 power minus 3, 10 power minus 3. If we cancel, then we have 0.1 by 5 minus 1. Sorry. It is 0.1 by over 5. Okay, minus 1 by e power t by tau. This will be 1 by 5. 1 by 5 minus 1. minus 6 by 2. Yes, therefore, how much this value? 220 by 2 is 110. 10. E power 0.1 by 5 is 1.02 minus 1 over e power 1 by 5 is 1.221 minus 1 minus 3. Okay. So hence what is the total value? This is 9.95 minus 3 is approximately 6.95 amps. 6.95 amps. So therefore what you can say, IO min is 6.95, IO max is 9.033. So therefore the current will be regulate between 6.95 to 9.033. Okay. Yes, one more problem. A DC chopper is used. A DC chopper is used to control the speed of separately excited DC motor. To control the speed of separately excited DC motor. Okay. The DC supply voltage is 220 volts. DC supply voltage is 220 volts. Armature resistance is 0.2 ohms. 0.2 ohms. And motor constant Ka pi is equal to 0.8 volts per rpm. Okay. The motor drives the motor drives motor drives a constant torque load constant torque load requiring an average current of 25 amps. Average current of 25 amps. Average current of 25 amps. Then determine first one the range of speed control, And second one, the range of duty cycle. The range of duty cycle. Okay. Assume the motor current to be continuous. Assume the motor current to be continuous. Assume the motor current to be continuous. Yes, already we solve this kind of problem. Yes, so how we solve? The range of speed control, in the sense minimum speed we assume as 0 and maximum speed we form. The range of duty ratio, in the sense maximum duty ratio we assume, that is 1, and a minimum duty ratio we form. Okay? Yes, let us we find. Yeah, the first one is the speed will be 0 when back EMF is 0. That means we can write VA is equal to, that is VA is equal to EB plus IARA. Okay. So here when speed is equal to 0, back EMF is 0. Therefore, this is 0 plus IARA, which is equal to IARA only. Okay. When speed is equal to 0, then VA is equal to IA, in the sense 25 he has given, resistance is 0.2, this will be 5. Okay. And we know that VA is equal to gamma into VS. VA is equal to gamma into Vs. So, unless he states that the chopper is step up chopper, so we consider the VA equation as gamma into Vs only. Okay. Therefore, gamma is equal to 5 by Vs. So, hence it is 5 by 220. That's how much this value? 5 ones are 5 fours are 5. So, therefore, it is 1 by 44. Yes, when speed is equal to 0, then gamma is equal to 1 by 44. These two are, we can assume, minimum and minimum. Okay, now we go to the extreme level, that is maximum. Yes, so how we find maximum? Yes, here we assume gamma is equal to 1. Then what is Vs? What is VA? VA is equal to gamma into Vs. This is 1 into 220. This value is 220 volts. Okay. Then what is EB? EB is equal to VA minus IA into RA. Yes, where VA is 220 minus IA is 25 and 0.2. Yes, hence the value of EB is 215 volts. Yes, 215 volts. So, and we know that EB is equal to Ka pi into N. Why I have taken N? In the sense, here he has given the Ka pi constant as 0.8 volts per RPM. Yes, as he has given the motor constant in RPM, so directly I have taken speed in RPM. So, hence N is equal to EB by Ka pi Thus, where EB is equal to 215 over 0.8. This is 268.7 RPM. 268.7 RPM. So, hence, what you can say? The speed is maximum. The maximum speed is 268.7 RPM when maximum duty ratio, that is gamma, is equal to 1. The minimum speed in the sense 0 at minimum duty ratio of 1 by 44. Okay. Yes. Now let us see one more problem. Yeah, here he has given the two problems merged. So let us see those two. A chopper fed from a chopper. This is A. Yes, a chopper fed from a chopper fed from a 220 volts DC source, 220 volts DC source is working at a frequency of is working at a frequency of 50 Hz, and it is connected to and it is connected to and it is connected to RL load, where R is equal to 5 ohms, R is equal to 5 ohms, and L is equal to 40 millihenries. L is equal to 40 millihenries. Determine the value of duty cycle. Determine the value of duty cycle. Determine the value of duty cycle at which the minimum load current is 20 amps. Minimum load current is 20 amps. Okay, and B problem is for the value of duty cycle obtained in A. For the value of duty cycle for the value of duty cycle obtained in A, calculate corresponding values of calculate corresponding values of corresponding values of corresponding values of maximum current and ripple factor. Maximum current and ripple factor. Yeah, so indirectly he says that first case we need to find out the gamma. That means in previous cases we used to give gamma and all the values, but we need to find only IO min, IO max like that. But here he has given the all except IO min, except gamma. So therefore we need to find gamma. So whatever the value found gamma in the first case, we need to use that gamma in the second, and for that gamma you need to find the IO max and hence ripple factor. Okay. Yes. Yes, here we do find both ripple factors, that is current ripple factor and voltage ripple factor. Yeah. Yeah, the first one is he did not give an E value, that is EB. Back EMF is not there because the load is only RL load. So hence one term is missing in the IO min and IO max. That is, yes, we know that IO min is equal to, yes, IO min is equal to, yes, IO min is equal to Vs by R e power T on by tau minus 1 over e power T by tau minus 1, and there is no EB by R. Okay, so he has given this value as Vs, we know 220 by 5 into e power T on, we don't know, T on we don't know, by tau let it be as it is, we will substitute later, minus 1 over e power, yes, T by tau. T is equal to, yes, what is T? T is inverse of frequency. The frequency is 50 Hz. So hence inverse of frequency, T is equal to 1 by 50. This is, I think, 1 by 5 is 0.2, and 1 by 5 into 10 power minus 1, that is 0.0. So that means finally we will get 20 into 10 power minus 3 seconds. And similarly, what is tau L by R, where L is equal to 40 millihenries, 40 into 10 power minus 3 over R is 5. So then how much it is? It is nearly 8 into 10 power minus 3 seconds. 8 into 10 power minus 3 seconds. Okay, now let us substitute these two values here. Yes, let's substitute these two values. E power T by tau. So T is 20 into 10 power minus 3 over 8 into 10 power minus 3 minus 1. Yeah, so ibomin he has given as 20. 20 is equal to 220 by 5 is, I think it is 45. 45 into e power T on by tau minus 1 over e power 20 by 8 minus 1. 10 power minus 3, 10 power minus 3 cancel. Okay. Then here we can also write this equation as find e power t on by tau minus 1. How much this value? Yes, e power t on by tau minus 1 is equal to 20 into e power 20 by 8 minus 1 divided by 44. Okay. This value is approximately 12.18. That is 20 into 12.18 over 44. This is equal to 5.53. Then what is e power t on by tau? E power t on by tau is, yes, is it 5.53? Just check once. Check this value. I hope this is not 5.53. Yes, whatever it is. So I got this value as, so let me check once again. This is approximately 4.96. For e power t on by tau is equal to 1 plus 4.96, which is approximately 5.96. Okay, and therefore what is t on by tau? If you take ln on both sides, ln on both sides, that is ln of e power t on by tau is equal to ln of 5.96. Yes, ln of 5.96 is 1.78. Therefore, e power t ln ln e power t on by tau is t on by tau only. So therefore, t on is equal to 1.78 into tau, which is given by, yes, 1.78 into time constant is 8 into 10 power minus 3. So this will become 14.28 milliseconds. 14.28 milliseconds. Therefore, what is gamma? Duty ratio gamma is equal to T on by tau, which is given by 14.28 over 20. T on by T is not T on by T, 20. 0.714. This is approximately 71.4%. Now, in the second, you need to find maximum current, maximum output current. So, for this 0.714, you need to find out maximum current as IO max. Find out that. As B, IO max is equal to Vs by R 1 minus e power minus t on by tau over 1 minus e power minus t by tau. Yes, whatever the value you are calculating now, this must be more than the 20. That is minimum value. Otherwise, our calculation is wrong. Yes, otherwise, our calculation is wrong. Yes, let us do this. Says Vs by R. 220 by 5 into 1 minus e power, what is t on 14.28 milliseconds, minus 14.28 milli over tau is 8 milli. Therefore, 10 power minus 3 will get cancelled, divided by 1 minus, yes, 1 minus e power minus 20 by 8. Okay. Now calculate this value. Yeah, this is approximately 40.78 amperes. 40.78 amperes. Okay. Yes, then what is ripple factor? So here you need to find the ripple factor for current as well as voltage. I told you. Yes, that is ripple factor of current. That is current ripple factor. Current ripple factor, CRF, is equal to IO max minus IO min over Vs by R. This is steady state current. Okay, so this can be calculated as 40.78 minus 20 over 220 by 5. Yes, hence how much this value is 20.78 over 45. This is 0.461. Current ripple factor is 0.461. Then what is voltage ripple factor? Voltage ripple factor. Voltage ripple factor, VRF, is equal to, we have the formula. What is that? Square root of 1 minus gamma by gamma. Square root of 1 minus gamma by gamma. So this is 1 minus 0.714 over 0.714. This is 0.6328. 0.6328. Yes, so let me stop here, and in the next class we will see some more problems. Okay, I hope all are doing good. Stay home, stay safe. I pray God to give good health to you and your family. Thank you for listening the class. Thank you once again.